Okay, so we're going to start with a short review on what kind of questions come up with integral as accumulator. One of the things to remember about integral as accumulator is that the defining feature of these problems is that we are given a rate in a context of a real-world problem. So we have a rate function given in a real-world situation. Okay, now what that happens with that is we'll be given a lot of questions concerning that rate. And so, common questions that will come up is they'll ask us for how many, they might ask for how much, and these are getting really at the big idea of the integral as accumulator. And to figure out how many or how much, what they're really asking us to do is they're asking us to integrate between two time values over our rate function. So the rate function is our integrand, and that's done with respect to time. And what that rate function gives us when we integrate is it gives us total change, or what we call total accumulation. And that's where we get this concept of integral as accumulator. Okay, and if you can master that on one of these questions, you're probably good for 2 to 3 points, just by being able to get that piece down. The next common question, since we're talking about rates of change, is that we'll get some questions that are concerning whether the rate or the number of something is increasing or decreasing. And not only will they ask us about increasing or decreasing, you can also count on some sort of interpretation to be asked about as well. So anytime we're asked about increasing or decreasing, that's really where we're concerned about what our derivative is doing. And so to answer that question, we really just need to look at the sign of the derivative. Now, what can get confusing is at times that derivative is actually already the rate function that's given to us, and sometimes we have to take the derivative of the rate function. So we have to read closely, and hopefully after we do some examples that will make a little more sense. But if our derivative is greater than 0, that's going to imply that our function is increasing. If our derivative is less than 0, that's going to imply that our function is decreasing. And my advice to you is that in this part about interpretation of this is that you're really going to have to watch your units. Make sure to include them, especially if the question is asking for that. Okay, another common type of question. You may be asked about finding an absolute max or minimum. Now, rarely will it actually say the absolute part, but it will just say minimum or maximum. And so for this piece, what you're going to need to do is you'll have to find where the rate equals 0, or we can also think about where the derivative is equal to 0. If we can find where the rate equals 0 or the derivative is equal to 0, this helps us find the critical values. So find where these are equal to 0 for critical values. Now, critical values are places where a minimum and maximum can occur at. But we also need to test the endpoints when it comes to an absolute maximum or minimum. So after you find the critical values, then make a table to test endpoints and critical points for minimum and maximum values.